Imagine a machine so powerful it doesn't just calculate, it rewrites reality itself. A computer that can break every encryption on Earth in a single night. A machine that doesn't choose between 0 or 1, because it chooses both at the same time. This is quantum computing, not the hype you hear in the news, not the sci-fi fantasy from Hollywood. This is the real story, the parts they keep hidden, the breakthroughs reshaping global power, and the dangers no one is ready for. Quantum computing isn't just a new type of machine. It's a new way of thinking. While classical computers process information in a line, quantum computers operate inside the bizarre rules of quantum physics, where particles teleport, reality flickers, and logic bends in directions humans were never meant to understand. Billions of dollars are being funneled into quantum labs. Governments are racing. Tech giants are competing. Because whoever wins this race will control the future of computing and perhaps the future of the world. A classical bit can be 0 or 1. A quantum bit, a qubit, can be 0, 1, or both at the same time. This is superposition. It allows quantum computers to explore millions of possibilities in a single breath. Where a supercomputer must try solutions one by one, a quantum computer tests them all simultaneously. It's like running every path, every outcome, every scenario at once, and choosing the best one instantly. Then comes entanglement, a connection so mysterious Einstein called it spooky action. Two qubits become linked. What happens to one instantly affects the other, even if they're miles apart. This gives quantum computers coordination and speed, beyond anything classical machines can achieve. It's the foundation of their terrifying power. Quantum computers can simulate chemistry at an atomic level. They can examine proteins so complex. Today's best supercomputers fail instantly. They can design new drugs, new materials, new energy systems. They can optimize city traffic, global shipping, supply chains, climate predictions. They can restructure the entire financial system by seeing patterns humans have never detected. And in the wrong hands, they can destroy the digital world in seconds. Every password, every banking system, every crypto transaction, every military code relies on encryption. Encryption that was designed for classical computers. Quantum computers can break many of these systems instantly, not by guessing the password, but by ripping apart the mathematical foundations behind it. When the first fully error-corrected quantum computer goes online, everything we consider secure today won't be secure at all. Right now, a silent war is unfolding. The United States, China, Europe, even private companies. The race for quantum supremacy is the new space race. But the public hears almost nothing about it, because the stakes are too high. The first nation to build a stable, scalable quantum computer wins a geopolitical advantage greater than nuclear weapons. They get access to every encrypted system. They gain unimaginable intelligence power. They gain economic leverage like never before. This isn't competition. This is survival. The media shows glowing cubes and sci-fi screens. Reality couldn't be more different. Inside the labs, quantum computers are fragile, chaotic, and incredibly unstable. They collapse from noise, from vibration, from temperature shifts smaller than a human breath. A slight disturbance causes the entire system to lose information. They require cooling near absolute zero, using million-dollar cryogenic chambers. They take entire teams just to maintain. Progress is slow, painful, and expensive, but the breakthroughs keep coming. In 2025, something changed. Scientists revealed a new generation of error-correcting qubits. These qubits could remain stable longer and perform more calculations before collapsing. It was the moment quantum computing shifted from theory to something functional. Quantum processors began moving toward real-world use. AI training accelerated. Molecular simulations improved. New materials were discovered. The world quietly crossed a threshold, and most people didn't even notice. Now imagine quantum computing combined with artificial intelligence. AI already transforms data at a scale humans cannot match. Put that on top of quantum acceleration, and you get a level of intelligence that can solve national-level problems in minutes. Drug discovery, defense planning, climate engineering, economic forecasting, anything involving massive data gets pushed into a new dimension of speed and prediction. Some scientists call this the dawn of superintelligent AI. Others call it a warning. Quantum computing won't stay locked in labs forever. Within the next decade, you may see medicines designed specifically for your DNA, energy grids that manage themselves, financial systems that predict volatility before it happens, cars that think thousands of steps ahead, AI assistants that simulate entire futures to find the safest or most efficient outcome. Quantum computing won't just reshape industries, it will reshape personal life, medical care, and global economics. But there are risks. Quantum computers could shatter digital privacy. They could erase blockchain security. They could enable cyber attacks that governments cannot defend against. They could destabilize global markets. By predicting and exploiting micromovements, they could unlock biological simulations that require intense regulation. Powerful technology always comes with shadows, and quantum computing has some of the darkest. There is another danger: the gap between nations that have quantum technology and nations that don't. A world with quantum haves and quantum have-nots creates an imbalance never seen before. Countries without quantum capability could be locked out of global progress, locked out of medicine, locked out of finance, locked out of security. Quantum supremacy isn't about who gets stronger. It's about who gets left behind. In the next 5 to 10 years, we will likely see quantum systems integrated into AI development, medical research, climate engineering, and military strategy. Quantum will move from labs into cloud services, universities, and industries. It will become a foundation of global infrastructure, not a toy, not a prototype, but a backbone of modern civilization. Every breakthrough in human history comes with a cost. Electricity, nuclear power, the internet, artificial intelligence. Quantum computing will be no different. It can elevate humanity, or it can expose us, can solve impossible problems, or it can create new ones beyond imagination. The question is no longer whether quantum computing will change the world. It already is. The only question left is who unlocks its full power first, and what they choose to do with it.